So growing up, I spent a ton of time with my grandparents. And in a hallway downstairs, they had this map. I mean, it was the most amazing, huge map. And it drew me again and again and again. The scale of it, the depth, the texture, like there was so much in the world to see. And after years of seeing this map, I had this epiphany. I was like, someone made that. Like a lot of someone's made that. A designer, a finder, someone who like found really amazing information and had the tools to make it real, to share that. So, you know, in the 1400s, someone had that idea. They said, it's going to look like this, right? It's going to be amazing. It probably looked more like that. Also amazing, but maybe it's not exactly what they had in mind. And that really brings us to Harry Beck. He was a technical draftsman for the London Underground. He drew electrical circuits. And Harry had an idea. What if a map didn't have to mirror the physical space? What if people really just needed to understand the connections and how quickly to get to the places that they wanted to get? He began to look at this existing map and think about his experience as a draftsman. And the result in 1931 was transformative. Every transit system has changed because of that. He had an idea and wanted to understand how people navigate underground, in the dark. There's no translation to the space above. And he had a tool. He understood drafting. That takes us to Massimo Vignelli. Massimo took this idea to the New York Metro. In 1972, he worked at Unimark. And he really expanded this idea into a citywide signage and wayfinding system. And Massimo did what all great designers and finders do. We set context. We anticipate a little bit. We suggest, and we're kind of demanding sometimes as well, right? And the tools that evolved from Harry's time, right? He wasn't a draftsman. He had really interesting tools. He was able to have paste ups, blue lines, and a lot of rubber cement. There was a trade-off with these tools. We had to sacrifice a lot when we had paste ups, right? So we go to the 90s, right? My 90s is a little bit different. I don't know. I lived in a different world. So we jumped to digital toolchain, right? We had the ability to have digital imagery. We could make type do anything we wanted. We were unbound by the limits of paste up. We could move really, really quickly. David Carson's work at Raygun, I mean, it pushed editorial storytelling to the breaking point. And his combination of information in that really unique time allowed him to force people through the content in completely new ways. His fingers were safe. His fingers were safe, but we found new limits. We could move quickly, but it took a while. We were pushing the capacity of 132 megahertz, right? We were constantly swapping floppies and SideQuests and zip disks to get enough information on the drive. So our tools, thankfully, it's been a while. The rock looks a lot different than that last photo. Our tools have changed a ton. But what if we didn't have limits? What if capacity and storage no longer became issues? What if we could take that away? That's our goal at AWS. That's what we're here for. We remove barriers and we create tools to allow people to find what's next. We have capabilities services in 20 categories. We started with things like compute, storage, networking, and we needed those things to build on. Those are the bedrock of everything we make. We make little of them, but they're the bedrock. We, on top of that, have built 130 services which are now available. Everything, all of the acronyms, right? We've got IoT, we've got AR and VR, we've got machine learning, we've got language processing, we've got video production, you name it. And if it's not up there, it's coming soon. We got somebody working on this. But that doesn't really yet solve well, it's still slow, Matt. Well, think a little bit about what it takes to run a $9 billion business. That's basically what Amazon was in 2005. And at AWS, we install that amount of capacity every single day. And we've been doing that since 2015, and it's accelerating. So if you have this amazing problem you want to solve, and you need 1 million processors, 2 million processors, okay, that's okay, we got that. So that's speed. We got speed figured out. Let's do that. But in order to take an idea, I need information. I need that information not at small scales. We want to solve exabyte problems. That's 1 billion gigabytes. So to give this a little bit of context, to transfer that much data, if I had a dedicated connection, fastest you can get 26 years. Start today, I'll wait. We had an idea. You remember thumb drives, right? The sneaker net. Well, we invented a bigger sneaker net. We went a little bit bigger. Our sneaker net is 100 petabytes. So you pull this thing up, it's called a snowmobile, lovingly. And basically that turns 26 years to 6 months. That's almost there. We're on the way. We can do that. I don't know if you can get bigger than 40 foot in a shipping container, but we're working on it. We're going to get compression. So we've got speed, we've got storage, we've got an amazing foundation of tools. So what now? How do our tools evolve? What if our tools started to work with us? What if we were able to collaborate? Autodesk is doing some really interesting work with generative design to help create collaborative tools. So instead of slowly iterating through and prototyping, what if we used goal-directed inputs? We said, I want to build a chair. I think it should support about 250. Unfortunately, I wouldn't be able to sit on this chair. It needs to weigh itself about 15 pounds, and I think it should cost about 30 bucks. So you then begin to collaborate with machine learning models, with the information for material science and manufacturing processes, and throw a lot of compute at it. And in real time, you look at all the possible variations, and then you can actually get in and manipulate. You can start making trade-offs and understanding why those variables change. I can optimize for aesthetics. I can optimize for cost. I can optimize for weight. I understand and can explore a much more expansive problem space. But that's just a chair, right? That's static. Let's get something that moves, something that has stress over time. So look at a car chassis. We've got the ability to create that initial prototype, but then load it up with IoT sensors and get it out on the track. Let that thing run, and then run it through the model. Let the data begin to inform the process, the collaboration that we have with our tools, and create something that was completely impossible and infeasible before, but functionally better and arguably beautiful. So that gives us static images, or static products and things that move. What if we want to track a ton of things simultaneously? Well, the Major League Baseball is actually doing that. They wanted to be able to capture, analyze, and predict all aspects of gameplay in real time. They actually did it fairly simply. They just added 3 sensors to every stadium around the world. They put one behind home plate that tracks the ball. and they put 2 cameras on third base, and that tracks all the players. So it gives you positional data for everything that moves real time everywhere. It gathers 7 terabytes of data per game. That's 17 petabytes in a season. We got that. That's nothing. But it opens up the possibilities for broadcast, for engaging with content. We actually know if that guy is going to hit home base because we know his foot speed. We know how fast he started, and we can predict if he's going to get there or not. Stop. Go back. You're not going to make it. Just look at the TV. So you've got this really interesting ability to change the game. I mean, talk about Moneyball, right? Like, this is the real deal. A lot of other sports leagues are interested. The NFL's got a version of this, and many more are coming. But we should kind of think bigger, right? Let's think at a planetary scale. AWS has had this really unique opportunity to work with a number of companies to create open data sets. We've got 15 right now. One really, really interesting one to just open the sense of possibilities is actually the 1,000 Genome Project, which ironically has 2,500 genomes in it, but we'll let them catch up. It fundamentally changes medical research. It's free. It's there. You can use it today. Good luck. It's really complicated. We also have the ability to see the planet and see it through time. We've got NextRad data for weather. We've got Landsat information for kind of updated hourly across the entire globe. Now, imagine how much you can do with that, whether you're a climate scientist, an architect, an archaeologist, a city planner, a startup. That's an interesting place to start. Your data set and your tools change what's possible. The Earth's great. Let's go one more out. NASA and JPL have worked with AWS for the last 6 years. I'm sure you guys have seen the Mars rover photos, right? Every one of those photos and all of the information that you've seen first went through AWS. Initially came down, it's cataloged, it's analyzed, and then it's stored and broadcast through our company. That's a gift to the next generation. That's something that is humbling, and it never pays to think big. Go bigger. So at AWS, we really work to remove all of these barriers for students, for startups, for the Fortune 100, and for governments all around the world. Whether you are really interested in inventing a new economy and letting people feel comfortable wherever they are in the world, if you want to protect a precious resource and create a smart irrigation system with IoT, saving 9,000 gallons per household. If you want to remove educational barriers and provide an Ivy League education to anyone. Okay, maybe you just want to entertain people, but create and broadcast that content to over 200 countries. Or maybe we can, as many people have talked about today, build a place where people can dream. This is the biggest visual bookmarking tool. They've got over 50 billion pins we can lose ourselves in. Find beautiful rooms, hopefully build a great roof deck. Everyone here, everyone in this room holds a key to the future of finding. Let us know how we can help. I can't wait to see what you're going to build next. Thanks.